Welcome, everyone, and thank you so much for joining us today. My name is Susan Welton, Oracle Marketing Manager at Perficient, and I'm excited to be moderating today's webinar on Big Data and Oracle Analytics Cloud. We're very fortunate to have Shiv Bharti and Mazen Manasa on the Oracle, with the Oracle Business Analytics team on the call with us today. They have a full hour planned, and I expect that you should grab yourself a cup of coffee or tea and sit back and enjoy, because they are going to cover the opportunity that big data presents and how you can capitalize on this tremendous asset with Oracle Analytics Cloud. I always get two questions that come up with our online events. Can I get a copy of the slides again? And can I get a link to the recording? And the answer to both questions is yes. We will definitely email you with the information on how to access both the slides and the recording following today's event. Time permitting, we plan on having a Q&A session at the end of the event. But again, we do expect a full day of presentation, or a full hour rather of presentation. So I would recommend, as you're watching and listening to the event, if questions arise, please do take the time to type your questions into the chat box at any time throughout the event, so we make sure that we do at least get your questions captured. Without further delay, I'd like to introduce today's speakers, Shiv Bharti and Mazen Manasa. Shiv is the Director of Perficient's Oracle Business Intelligence practice. Shiv has successfully led the implementation of more than 75 Oracle BI and custom data warehouse projects, and has helped countless clients across industries implement BI solutions to drive value with their technology investments. Mazen is a solution architect in Perficient's Oracle Business Intelligence practice. His data warehousing expertise, together with an in-depth knowledge of the OBIEE platform, is a result of 12 years of consulting experience. He focuses on assessing the health and scalability of existing client technologies, evaluating roadmaps and scope of new BI solutions, and managing delivery teams. Shiv and Mazen, welcome.
Thank you, Susan. Hi, everyone. Thank you for joining us for the webinar on how to capitalize on big data with Oracle Analytics Cloud. So let's take a look at the agenda. I would like to start by giving you a quick overview of Perficient and our business intelligence practice. I'll then talk about the opportunity with data and why is it being considered as one of the most valuable resources today. We'll then discuss the business challenges that organizations see and the key pillars that allow them to overcome those challenges. We'll then go over a few technical and business use cases and make our case for a big data platform. I'll then turn it over to Mazen to do a deep dive into big data architecture and discuss how Oracle can solve your needs. We'll also spend some time to talk about implementation approach, Oracle Analytics Cloud, and Data Lake. Finally, we'll open it up for questions from the audience. So who is Perficient? We are a leading digital transformation consulting firm serving Global 2000 and enterprise customers throughout North America, with unparalleled information technology, management consulting, and creative capabilities. Perficient and our digital agency deliver vision, execution, and value with outstanding digital experience, business optimization, and industry solutions. We have a broad network of locations across the U.S., as well as offshore facilities in India and China. Founded in 1997, we are a public company with nearly 3,000 employees. We are an Oracle Platinum partner and have dedicated pillars for Oracle ERP, Business Intelligence, Enterprise Performance Management, and Customer Relationship. A little bit about our Oracle BI practice. Our Oracle BI practice has over 14 plus years of experience deploying business analytics product stack. We are a team of over 200 consultants, very similar to our background. I would say about 65 to 70% of our consultants come from product development, who played a key part in building some of the products that we continue to successfully deploy at our customers. Over the last few years, our team has been assisting our customers with business optimization projects by building a modern data platform on Oracle Analytics Cloud. So with that, let's jump right into it. A lot has been written about data as the world's most valuable resource and the opportunity that it presents to organizations today. Organizations have begun valuing data as an asset on their balance sheets. Data is woven into the fabric of every company. It records what happened, but increasingly, it's being used to drive change and transformation at unprecedented rates. Any business leader looking to maximize their data needs to ask themselves, does your organization have a comprehensive data strategy? Does that strategy address both structured and unstructured data? Do you have a platform that allows your organization to analyze transactional data and social sentiment? If you answered no to any of these questions, chances are you have untapped data resources or at the very least underutilized data resources. You are probably aware that you have this asset and you need a plan to leverage. But how big is that opportunity and how valuable are your data assets? Experts claim that there is a 10x return on investment in business intelligence. For some organizations, that's the low-end estimate of value they have created. Industry analyst firm IDC has even estimated there is a $430 billion economic advantage to organizations that analyze all data and deliver actionable insights. The bottom line is that the opportunity is big and growing. Data has been doubling every couple of years for a while now. With the exponential rate of growth in data volume and data types, traditional data warehouse architecture cannot solve today's business analytics problems. You need new approaches to handle the growing complexity while trying to maintain their expenses and staying ahead of the competition. Also, your customers, channels, and competitors are digital, so are your employees and increasingly even your products. Digital transformation is critical, and according to Forrester, 89% of executives see it impacting their business in the upcoming 12 months. And that survey was taken in 2017. Finally, machine learning is more than just a buzzword. It's a core part of the solution. For many, even most companies, it's the most important part of the solution. With the arrival of big data, the data itself is quite complex, as are the interactions between different data sets or types of data. Machine learning algorithms are able at some level to figure things out for themselves. The point is that there are new types of business challenges that organizations are facing today. To get the most return from your company's data capital, you need to be well versed in transformative technologies that are available today and approaches that you can use to reduce cost and yield valuable business insights. You should plan to invest more in advanced analytic tools to get the most value out of big data that you continue to accumulate over time. Now, data comes in many forms. Structured data from business systems, unstructured data from inside and outside your business, documents, tweets, social media, even in-motion streaming and real-time data. Most IT and business people know there is tremendous value just waiting to be tapped. So what are organizations asking for? What are they demanding from a modern business intelligence platforms? First, it's getting access to all the data they need, data to inform every decision when and where it matters. They want to rely on a modern algorithm to crunch their data. Pretty much any machine learning algorithm is likely to give better or more accurate results when there's more data for it to work with. Whether you're trying to build a better view of your customers' wants and needs or figure out why a component is breaking, you have got to start with as much data as possible. Second, data science is becoming a key part in enabling organizations capitalize on their data. Companies are looking to use data science and figure out how to incorporate it into their businesses. Finally, they want all the data and all of these algorithms and this modern technology to be put to work in support of the applications that are used to run their business. For example, if you look at Oracle's Adaptive Intelligence application, it combines artificial intelligence, machine learning, and decision science with data that is captured from Oracle SaaS applications as well as other third-party data. The unique value of these learning-enabled applications is that they detect trends, learn from results, and most importantly, increase their accuracy the more they are used, adding massive amounts of contextual data to a clearer picture on what motivates outcomes. So before we get to discussing technical and business use cases, there is one polling question. So let's take a look at that. So you should be able to see this in front of your screen. Does your organization leverage machine learning algorithm to gain insights from unstructured data? So you can go ahead and select your response. The first is yes, machine learning is being used in your production environment, or you have an active pilot project going on, or maybe you don't have a project plan in 2018, no pilot project plan in 2019 either, or the last one is no project plans to explore machine learning. So so the responses are coming. Let's take a look at the results. So it looks like 33% of you are already using this, which is great. And I would say in total, at least 55% of you are familiar with this. There's an active project going on, or machine learning is being used already. So that's great. Okay, so with that, let's deep dive a little bit and discuss a few technical use cases or challenges that can be addressed with a modern data platform. Now, ability to integrate data from any source is one of the key technical requirements of all modern data platforms. Most often we come across data spread with varying degrees of structure, complexity, and quality all over the enterprise and outside the company, with the addition of sensors to various internet-enabled devices as well as Facebook, machine logs, and web commerce. The variety of data continues to increase. Now, big data needs to address the different types of data being created. We need to make sure that all this data is available for decision making. Now, if you are a data architect or anybody who deals with data for that matter, you could realize that requirements for data processing keep changing. You need more access to more data. You need to ensure that data is available real time. You cannot ignore the fact that whatever data is being used is trustworthy, enriched, and of the best quality. The modern data platform should ensure that you are covered for all your data migration, data transformation, data quality, and the data governance requirements. Next technical requirement is to be able to store all data types and at scale. While the data warehouse remains an essential component of any information architecture, not all data belongs in the data warehouse. Sometimes it's just too huge, too old, or not valuable enough to go in the data warehouse. Customers still want to keep and work with that data and to look to put it in a data lake, not the data warehouse. Now, for those of you that are not familiar with the data lake, essentially it is a reservoir or a repository that holds disparate data of all kinds in its native format. Now, one of the key differences between a data lake and a database is, in a database, when data is being inserted or added, there has to be a well-defined table structure or schema in place. In the case of a data lake, there is no need for any table structure. All data types in their native format can be stored in the data lake. So you can store the data, raw sensor data that customers would not want to put in their data warehouse, process that data, that is transform them as a part of the extract, transform, and load workloads, and load results. Imagine running a machine learning algorithm on a large amount of data in the lake and then uploading the results or summary directly to the data warehouse. All of this is possible because the data warehouse can query, write to, and read from object storage, which is where the data lake data is kept. Now, of course, it's not the static data that matters. Any big data platform has to take into account of data that is in motion or streaming data. This might include live streams from IoT or Internet of Things sensors, or live transactions from your OLTP system, or anything else in motion for the matter that is captured, processed, and stored. Now, improving performance without having to consistently create aggregate tables as your data continues to scale is a prerequisite for all modern data platforms. By inserting an in-memory layer between the data lake and the tool that need to use it, data science tools, anything using SQL, analytics, or business intelligence tools, instead of querying the data lake directly, these tools end up working with the data that is cached in RAM. This means that the queries can be up to 10x or even 100 times faster. And lastly, a data catalog. This can really facilitate user adoption of a modern tool. A catalog would be a key to being able to make productive use of data. It's essentially, you can think of it as your data dictionary that keeps information regarding the data attributes that are available, who is the owner, the business definition, and the lineage information for different business metrics. It can also provide recommendations based on the analysis or report you're trying to build. So those were the technical use cases of a big data platform. Now let's discuss business use cases. It's an old joke in advertising that you're wasting 50% of your budget and you have no idea which 50%. Well, you don't have to waste that budget today. By using a clustering algorithm, you can find groupings of things, customers in this case, that are similar in some way. Now, this approach is very common for customer segmentation. So you could identify customers with similar interests or issues and market to them appropriately. Clusters can be created with just 2 or thousands of attributes using things like what they purchased and when they looked at, who they communicate with, and so on. So this technique can be used to optimize your marketing campaign spend. By examining the response rates of customers to different communication channels, we can project how many and what mix of communications will likely result in action. Using this approach, we can optimize how we contact our customers, both maximizing return and optimizing our marketing spend. Now, almost every organization or company wants to make sure their customers are given a better experience, no matter who they are, what they are doing, and where they are. But it's often a difficult task with competing priorities, fickle customers, and inability to truly know more about them. So these customers span across almost every dimension, from students and patients, online shoppers, citizens, and consumers. Getting more data isn't the answer. It's about using data to provide better products. It's about using information to personalize the shopping experience. It's about using data to discover new markets and better target existing ones. This is perhaps no more direct benefit to a company than its ability to translate their customer data into real-time recommendations for customers to purchase. When you search for an item on Amazon, the web commerce platform learns about your interests from your shopping and purchase behavior. It starts making recommendations for similar products as well as complementary products based on what other customers bought together. Now, you may not have been shopping for additional item, but the mere suggestion that other customers bought batteries when purchasing the same electronic toy may be enough for you to add it to your cart. Without the correlation data to make the recommendation, Amazon does not make the additional sale, and you end up with a toy without the right batteries. Better business for Amazon and a better experience for the buyer. The key technology behind this intelligence is a big data analytics platform that correlates customer service issues based on keywords and free-form text. It's a cost-effective way to store huge volumes of data to be able to perform advanced analytics on the collected data sets and to build predictive models that make those appropriate recommendations. Most importantly, the models can be improved over time based on user feedback. Now, improving the efficiency of existing processes may not be glamorous, but it matters a lot to a lot of customers. Taking something you are already doing, such as improve internal processes or optimize supply chains or accelerate compliance, these have a cost associated with them. And if you can do it more efficiently at a lower cost and with lower risk, it's a huge win and frees up budget that can be put to driving growth. As an example, Airbus used Oracle Big Data Solution to cut testing time by 30%. This is enabling them to ship a multi-billion-dollar project sooner than otherwise would have been possible. Finally, here's an example of using neural networks to predict attributes of the performance of a pump. The challenge of proper scheduling grows with the complexity of machines. In a system with many components working together and influencing each other's lifetime, how can we find the right moment when maintenance should be performed so that the components are not prematurely replaced, but the whole system still stays functionally reliable? Providing an answer to this question is the aim of predictive maintenance, where we seek to build models that quantify the risk of failure for a machine in any moment in time, using this information to improve scheduling of maintenance of the machines. The success of predictive maintenance models depends on having the right data available, framing the problem appropriately, and evaluating the predictions properly. So when people think about big data use cases, new business models and exciting new innovations are what comes to mind. Uber, Airbnb, Facebook. And while new possibilities are undoubtedly an option, more often than not, they are not the first big data project in most companies. In fact, earlier projects that help to prove the technology on something simpler can be a springboard for something new. So look around your business and see if there are any opportunities to solve new problems with new data. Could you combine data from devices, sensors, customers, and analyze that in real time to react better and faster? Is there a way to pursue a new opportunity in an adjacent market? The technology is there that can answer those complex business questions that you may have. So with that, let me go ahead and turn it over to Mazen. Mazen, please take it away.
Thanks, Shiv. So now that you've looked at the different use cases or the value of using big data for our organizations, let's take a look at what does it really take to implement that, what does the architecture look like, and I'll talk about the different technologies involved. So when we look at the data lake ecosystem, there's different stacks technologically, starting with data integration, storage, processing data, and presenting it and applying machine learning algorithms as well. And within each of these stacks, there's different technological components. So traditionally, we talk about doing ETL, we talk about ODBC, JDBC connectivity, data warehouse. But now when we bring big data into the picture, there's a lot more technologies that are involved, and most of these are open source technologies, whether it's data integration with Kafka, Flume, or processing with Impala, Spark, and MapReduce. So our technology is now more diverse. There's more things to worry about. And if we compare the classical way of doing analytics versus dealing with big data, I mean, classically we hear from our customers that they want to compute profit margin in this way, or they do their employee transfer rates within their departments in another way. They know pretty much exactly how they want to do their metrics. And for that type of analysis, we follow what is called a schema and read. So we tap into our different data sources, whether it's an ERP system or an HR system. We create a schema, which is data model optimized for reporting, store the data, and then we analyze it. But now when we deal with the big data use case, we switch to a different paradigm, which is what we call a schema and read. So we typically hear from customers saying, for example, we need to use our website user interaction data, or we need to tap into our social media activity or the log files generated from our devices. And we know it's going to be helpful for our business, but we don't know exactly how we're going to use it or how to define our metrics. That's why we moved from a schema and write to a schema and read paradigm. And for example, look at collecting log files from devices, storing a Hadoop system, and then we do code to schema as we analyze the data, as opposed to creating a data model as we're storing. So things are a little different when we deal with large volumes of data. And with a big data solution, there's typically these challenges that I would want to talk about. First, we're talking about diverse data sources. So we're not dealing with a transactional system or point of sale system. We're talking about different APIs feeding data from all different directions. The technology to handle all those different sources is also different. And also, then we need a specialized skill set on all these different technologies, which also adds to the complexity. So to address these, we typically look for a comprehensive solution. That means a single platform that's capable of connecting to all the different sources, that's capable of supporting the different technologies to integrate with the sources, and it's also going to empower the business users to self-serve their needs. So we don't want to rely on data scientists all the time to run some machine learning algorithms to get the sense out of the data. We want to empower end users to self-serve their goals. So now that we've looked at, in general, what does a big data platform look like, what is Oracle's strategy for solving big data challenges, and what are different cloud service offerings from Oracle to address that? So if we look at Oracle's information management services, you're going to see there's a whole different set of services from Oracle to address big data and data lake solutions. And at the bottom here, there's a summary of what the data sources may look like. So there's structured data. This can be enterprise, ERP, sales data, marketing, HCM. But there's also semi-structured data like social media, Google Analytics, for example, and unstructured data. So these can be text files, documents, or log files generated from different devices. So there's a lot of diversity in the data sources. But really, when we look at an Oracle Cloud infrastructure, we're looking at an integrated platform. So we're making use of a single infrastructure to handle our security, handle VPN, for example, how to integrate a cloud platform with your on-premises data sources. And another example for cloud infrastructure is to handle object storage. So these would be shared components across the different Oracle Cloud products. So at the bottom of the stack, from Oracle, we have different data integration technologies. If you're familiar with data warehouses, you probably have heard of Oracle Data Integrator to integrate different data sources into a data warehouse. Golden Gate is an example of using real-time replication of data so you can report on real-time data. Oracle Data Sync is a relatively newer tool to integrate data from different sources into a cloud environment. And there's also the Oracle Event Hub Cloud, which is more tailored for big data streaming. So you're streaming, for example, Twitter feeds directly into your big data environment using Oracle Event Hub Cloud. And on top of the integration stack, there's the data storage stack. So here we have data warehouse, for example. And if you want to look at the latest and greatest, there's the autonomous data warehouse from Oracle. There's Oracle NoSQL database for semi-structured data. And there's the Oracle Big Data Cloud Service. And I'll deep dive a little bit more into each one of those products in a bit. So these would be where the data would be stored. And then if we want to talk about querying data now, there's the Oracle Big Data SQL Cloud. And that's what's going to allow us to write natural SQL to query data not from a relation database only, but from NoSQL and Hadoop file systems as well. Very powerful capability to put the data into the hands of the business analysts with ease and quickness without having to worry about all the big data technologies involved. And on the top of the stack here, we have the Oracle Analytics Cloud, which is abbreviated as OAC. So this is what's going to present data to the end users. There's no point collecting data and storing it if we're not going to be using it or making decisions based on it. And that's where OAC comes into play. And as I expand more about OAC in a bit, you're going to see that it's not just for presenting data, but also for ingesting, transforming data in a big data environment as well. All right, so I'm going to deep dive a little bit into some of these products. There's 5 of them that are listed here on the left side, so you have a better idea of which services to use for what purpose. So starting with Event Hub Cloud, that's going to be key when we talk about streaming data with low latency, high throughput, and it's really based on an open source Apache Kafka technology. So if you're familiar with that, that's what Event Hub is. It's hosted in Oracle Cloud, so it leverages the Oracle Cloud infrastructure, and there's native integration with Oracle Big Data Stack and the cloud apps. Oracle Data Integrator, that's been in use for a while now for building data warehouses. But what's key about this here is that it has big data capabilities. So it allows the developers to write data integration and transformation into big data Hadoop environments without having to learn all the different data science technologies with big data. It's all graphical. And once you execute the code, it's going to push down the execution to the Hadoop clusters. So you're still leveraging the power of Hadoop, but it's all tailored for the developers who are not familiar with the latest Hadoop languages. So easy integration between different platforms, whether you're going from HBase, which is a Hadoop storage system, to Oracle Database Relational, or HBase to Hive, Hadoop to third-party or third-party to Hadoop, all can be handled through ODI with a very familiar graphical user interface. Next here would be Oracle Big Data Cloud Service, and this is a big piece of the puzzle. So Big Data Cloud Service from Oracle is an enterprise-level pre-configured Cloudera distribution of Apache Hadoop and Spark that has the latest and greatest of the open source Hadoop ecosystem. So whether it's for stream processing, Apache Spark for machine learning, the Impala for ad hoc querying, and also a bunch of different technologies such as spatial, graph, R, and big data connectors. All that would be hosted pre-configured on an Oracle Cloud infrastructure, and that's ready to use, really. If we take a look at what Oracle Big Data Cloud Service looks like, it's, as I said, Cloudera Hadoop Enterprise, and from a storage perspective, we have got the HDFS, which is the Hadoop file system, that also has the NoSQL HBase as well. And layered on top of that, there's all the different languages, Spark, Pig, Hive, Flume, that are typical of a big data environment. So these are open source technologies that are very common in the industry, and they're already configured and installed for us. And on top of that, there's the presentation layer and where the machine learning kicks in with Oracle R, Spatial, Graph, and Notebook. And these are tailored for the consumer, like the end user, but I want to differentiate a little bit what that offers us versus what Oracle Analytics Cloud will offer us in a bit. And from a data integration perspective, we also talk about ODI. So if you subscribe to Oracle Big Data Cloud Service, part of that subscription is capability to use Oracle Data Integrator to load data, ingest data into the Hadoop environment. But also you can use ODI to extract data from Hadoop. If you look on the left side, there's a list of the different capabilities to extract data, like SQL connector, loader, xQuery, R, and ODI to easily tap into the Hadoop system and get data out of it. So next is the Oracle Big Data SQL Cloud Service, and this is going to be key if you have data stored across different storage systems. So you have your enterprise data in a data warehouse, then you've got some data laying around in a NoSQL database, but also you have the Hadoop file system. To get all that data together, Oracle Big Data SQL makes that easy because you're using a very common SQL language to query all the different sources. No need for the data science activities. It's all through SQL. And it has capabilities to extend the Oracle database security features to the data that is stored in Hadoop. And the final thing I want to talk about on this slide is the Oracle Analytics Cloud. So that's going to be the presentation layer for everything you have data in terms of Hadoop and non-Hadoop as well. It's for presentation of data, but it also handles ingestion and data transformation, as we're going to see in a bit, because it's tailored for the end user, and it's going to empower them to not just report on data, but also feed data into the data lake, transform it, and make it appropriate for reporting. So when we talk about data access, we have capability in OAC for visualizing data, building dashboards, doing self-service discovery, but also talking about mobile access as well. So if you're traveling around to different customer sites, use the day-by-day app from Oracle to get automatic insights through very innovative AI technology from Oracle to handle different customers at different locations. There's also pixel perf reporting embedded within OAC as well. That's from accessing the data perspective. When we talk about transforming the data and modeling, there's what we call data flows that a business analyst can use to ingest, blend, prepare, and store data. So here we're talking about connecting to sources, building a data flow, and then doing some transformation of some sort, and storing the data back into whether a relational database or into a big data environment. The execution of that data flow would be pushed down to whatever data storage layer we're dealing with. So whether it's a Oracle data warehouse or an Apache Spark environment, the data flow would be able to handle that at the appropriate level. OAC also has what we call pre-aggregate cubes with Essbase to provide for a very quick response time reporting. OAC also has big data connectors, so connecting through Hive, Spark, MapReduce, that's pretty easy using the connectors that are built into the OAC platform. And talking about Oracle Analytics Cloud, I just want to make everyone aware there's different editions available to subscribe to. So Standard, Data Lake Edition, and Enterprise Edition. And here's a quick comparison of what each of these would have. So when we start, all of them would have data visualization capability, self-service, but then when we get into the big data, data lake execution in Spark, that's where you want to focus on either Data Lake Edition or the Enterprise Edition. So when I say Data Lake Edition, I don't really mean that OAC is the data lake itself. It's more of a platform to process data lake data and manage the data lake, really. You would either want to have either an on-premise big data environment or Oracle Big Data Cloud service to go along with the Oracle Analytics Cloud subscription. So we looked at a different Oracle product offerings, and some of these have overlapping capabilities, but how do we know which one is best to use? So that's what I'm going to talk about next here. So we've got all these different Oracle Cloud data-related technologies on the left, and I'm going to try to map them to the roles on the right side. So starting with the data integration technologies, these are typically tailored here, as you see on the right side, to a technical skill set, whether someone from IT as an administrator to set up, or a data engineer or data scientist to build the data integrations. That's typically handled by technical staff. So when we look at above that, the Oracle Big Data Cloud Service, that's going to be primarily focused around data science. So a data scientist would be important in this case to handle data ingestion, transformation, and analysis of the data. It's not something that a typical IT administrator would be able to do. It requires data science to get that together. And if we look at Oracle Big Data SQL Cloud, the primary consumer of that would be someone who knows SQL pretty well. So if a business analyst is used to writing SQL queries, this is going to be very simple and easy to get going using Oracle Big Data SQL Cloud. And lastly here, Oracle Analytics Cloud, if you see here, the ingestion of the data, transforming it, doing machine learning and analysis, it shifts a little bit from a data scientist type of role to a business analyst type of role, because it's all done through a browser using drag and drop through data flows and data visualization. It kind of removes that dependency on a data scientist or data engineer to be involved. And the primary focus for OAC really is for the executives, the VPs, and the managers to get access up to the data through different channels, whether it's through email, mobile devices, or through dashboards. It's how to get the data into their hands. And the business analysts, of course, to do the ad hoc and self-service on all sorts of data. So now I'm going to talk a little bit about some of the best practices involved in putting together a data lake. And these are based on the key challenges we've seen. So it's really key to think about a cloud infrastructure for a big data ecosystem. Why? Because it's already configured and installed, so we're not spending time putting an environment together. It's all ready to get go, and we can then focus on the business value that we're after. And in addition to that, it stays up to date. So because the open source technologies around big data are continuously evolving, we don't want to kind of migrate every time there's something new. Focusing on a cloud infrastructure allows us to get that out of the way. Another aspect of the cloud infrastructure for big data is its elasticity. So we can start small based on a very focused exercise, but then we can scale up with more processing power or storage or memory, or scale out with adding more nodes to the Hadoop cluster pretty easily with a cloud infrastructure. And we also pay for only what we're using. We don't have to pay for a bigger environment if we're starting slow for the first year or two. We just pay for the environment we're using. Another best practice to always keep in mind that big data is not only a technology, but also a business driver. So data needs to be accessible by the right people. If we have a Hadoop environment loaded with all sorts of data, and we're relying on a data scientist to get things going, we're kind of blocking access to the data to one or two people. We want to open up the environment to allow the end users, the consumers, to tap into the data that is stored in an environment. And the last thing here mentioned is the machine learning capability. That is really key to succeed in big data. So historically, we do everything in a data warehouse, and there's not much that an Oracle database, for example, cannot do. Pretty much all types of data transformation can happen in a data warehouse. But what makes big data different is we now switch from talking about a terabyte size of data to petabytes. So when we get to that stage of data volume, we'll need a different environment altogether. And machine learning is going to be key because relying on humans to process data is not going to work. You need the machine to go and process data and figure out what's the best decision based on historical data, or give predictions based on historical data. So now I'm going to focus more on Oracle Analytics Cloud. How can we use Oracle Analytics Cloud to manage the data lake, not just from a data presentation perspective, but also from a data preparation perspective? There are really four main steps when we talk about managing a data lake. So when I say data lake, I mean not necessarily just Hadoop. I mean data warehouse, Hadoop, NoSQL. It can be data storage in any storage environment. The first step would be to discover data from different sources. The second step would be to prepare the data, which is integrate with the sources, transform it to a certain model that is consumable, analyze it, and also apply machine learning algorithm on top of that to come up with useful use cases. So starting with discovery, this is a screenshot of what OAC offers in terms of built-in adapters to connect to data sources, and that list is continuously growing. So it's going to make things easy to connect the sources and ingest data into the data lake. So whether it's a big data cloud service or an Oracle data warehouse, getting data into that data store is going to be an easy-to-do task using those built-in connectors. And also, when we talk about data discovery, we have to be aware of the different catalog assets that we have in OAC. And these are all tailored for an end user. So a business analyst, for example, can go and create projects. A project would be a dashboard like Canvas that has visualizations and reports. They can create connections to data sources, data sets. So these can be as simple as a spreadsheet in an Excel file, or it can be something coming in from Twitter or Facebook, or an ERP data source. Data flows and sequences, these are the transformations that all happen within a browser, ready to match data together from different sources, apply transformations, and sequence their execution. If you have dependencies across different data flows, all that can be handled within the OAC environment. Data preparation within OAC also is very straightforward to do. So it's spreadsheet-like. You get different functions to apply on top of the source data. And then data preparation through data flows is going to be key because this allows the business analyst to go in and join different data sets together. For example, you want to see the effectiveness of sales through an e-commerce website or through a mobile app. One data source would be the orders that have been placed, and then you want to match that up against the different clicks or the user interactions on a website or through the mobile device. So you get those different sources joined together through a data flow. Another typical example is for HR. You want to look at employee acquisitions through Taleo. So you have their acquisition data coming from Taleo, join that to the HCM system to look at employee career progression over time, all through data flow. So these are some of the examples we've seen typically implemented through OAC data flows. Now we get to the third step, which is data analysis. So that's where we talk about visualizing the data. There's a rich palette of built-in visualizations that keeps growing as well, but it also allows you to extend it with custom visualizations. So in this example, we're looking at a custom map of a stadium to look at, to analyze the occupancy across different sections of a stadium. So it's pretty open in what we can visualize in OAC. OAC for data analysis, there's the drag and drop ad hoc capability to visualize data, but there's also very powerful automatic machine learning insights, if you may, to look at anomalies within the data sets we have without having to do it ourselves. So if we're looking at segmenting your customers to see how you want to campaign for each groups of customers, OAC can look at different anomalies within the customer base and propose different groups that have common traits, so you can target different customer groups differently. That's just an example of how you may use that capability within OAC. Prediction. So in OAC, there's built-in time series forecasts. There's sentiment analysis, but you can also extend it with custom Python and R scripts if you have data scientists to do that for you. All that can be handled within the OAC environment. And machine learning. So the business analyst would be able to consume one of the many machine learning algorithms that are built in to create a machine learning model that is trained and scored based on historical data, and then apply it to the new data flowing in to predict, for example, if a sales opportunity is going to be a winner or if a project is going to go under budget. All these can be handled through the front end using data flows. So in addition to creating visualizations and data flows, the business analyst can also manage the environment. So running the different jobs at the right time, scheduling them to run automatically, and sequencing their execution is all done through the UI as well. And with that, I think I come to the conclusion of my segment. The slide here would give you direct links to, I hope, useful information about Oracle Analytics Cloud and Oracle Big Data Cloud, plus some links to very informative blog sites from Oracle to hear from the experts, and a very step-by-step guide about starting on big data. So with that, I'm going to turn it back to Susan to see if there's any questions if there's time to do that.
Thank you, Mazen. As Mazen mentioned, this was a very full information-packed event, so we only have a couple of minutes here for Q&A. But please go ahead and type your questions into the Q&A tab, and what we'll do is make sure that we get back with you. Again, a lot of ground was covered here, so I'm sure that you do have some questions. So feel free to type those in the Q&A tab now, and we will follow up with you. In the meantime, we did have a couple of questions that came in. And the first one here, Mazen, this looks like this might be for you. It says, do we need to consider an ETL tool and a traditional data warehouse in a big data platform?
Yeah, thanks, Susan. So ETL tool, we use typically ETL tools to build what we call data warehouses. And I don't think about big data as a replacement of data warehouses, but it more really complements the data warehouse. So we'd keep using an ETL tool for that. And if you think about ODI, for example, it can handle both traditional ETL capability plus the big data data preparation capability. So you would either keep what you're using or you extend something like ODI to handle big data as well.
Thank you, Mazen. Shiv, looks like we have a question here. It might be for you. How is machine learning being adopted by business users?
Yeah, so number of use cases that we are seeing, and Mazen covered some of that. One example would be to improve data quality. So with the volume of data, number of different data sources, it is not humanly possible to go ahead and try to manage that without using a machine learning algorithm to try and figure out which of those data are useful, have some insights that can add value to the business. So that's one scenario where we are seeing machine learning algorithms be used. Next is ad hoc capabilities, really to empower the business user. So the example would be, for example, if you're looking at an attrition, before as a business user, you have to go ahead and figure out attrition, throw in different dimensions. But now you could tell the tool, go ahead and show me the correlation that attrition has with whatever dimensions, or how many ever dimensions, or how many ever attributes. So that's another way to really empower the business users, from an ad hoc capability. And the third use case that comes to mind is improving predictive models, right? So if there are certain predictive models that you're building, you can use those machine learning algorithms to continuously improve the quality of predictions that can be made. So yeah, those are the three that actually comes to mind.
Thank you, Shiv. Well, we're really at the top of the hour. So at this point in time, I just want to recommend that you follow us online. If you haven't had an opportunity to check out the blog, the Perficient Oracle blog is a great blog. Mazen blogs, Shiv blogs. So there's really good content out there that is continuously shared by not only the BI team, but our other teams as well, ERP, EPM, and CX. I did also want to mention that Shiv has authored a guide called The Future of Big Data, Why Traditional Data Warehouses Won't Solve Your Big Data Challenges. We're about probably 2 weeks out from that guide being available, so if that's something you're interested in, please just make a note here in the Q&A tab, and I'll make sure that I get that guide out to you. So at this point in time, I want to say thank you to our speakers today, Shiv and Mazen, and thank you all for joining us on today's call. We hope to see you online in the future.